Assalamu alaikum everyone. This is Probability and Statistics for Engineers course in the Department of Civil Engineering, International Islamic University. Today in this lecture we are going to discuss about normal distribution. Okay, before starting normal distribution, let's preview continuous random variable, because normal distribution is based on continuous random variable. As I have already discussed about random variables, I have mentioned that there are two different kinds of random variable. One is discrete random variable, another one is continuous random variable. So if it is a discrete random variable, it will be a kind of for a discrete random variable, we will be having data like 1 2 3 5 7 8 11 12. So the data will be a whole number. But in case of continuous random variable, we will be having a data which is not in a whole number. For example, a temperature, we might have continuous continuous random variable as the temperature, that is 32.5 degrees C or 38.7 degrees C or in extreme cases 48.7 degrees C. So these are all continuous random variable. That the temperature is a random variable. They take different values in decimal, or I can also say the temperature of 40 degrees C. So that is also a part of continuous random variable. Okay, so if we have continuous random variable like a temperature, a height of people, or I can say other examples, like if you measure the area of a region, and you get different values for that area, the area might be 14.7 square feet, area might be 21.7 square feet. So the area in that form is a continuous random variable. Now let's talk about continuous random variable. A random variable, as I said, can be a discrete or continuous random variable. We have learned to handle probability distribution for a discrete random variable. We have already discussed about Poisson distribution, which is based on a discrete random variable. We have also discussed continuous distribution, for example exponential distribution. But let's talk more into the detail of continuous distribution. Here we are going to explain normal distribution. Okay, once again, continuous random variable are defined as variable that can assume any value between one or more interval. So if we have an interval of 1 and 5, if we have an interval of 1 and 5, so we might have different values. We have almost infinite number of values in that interval. But if we talk about the discrete one, so the interval of 5 and 1 will include 1 2 3 4 5, but continuous might be 1.5 1.9 1.7 1.773 1.245 or anything like this. These values are not countable because we have a lot of numbers in between an interval, so it's an infinite. These variable can assume infinite number of values because there are infinite number of values in any given interval, as I have mentioned now. Okay, also in normal distribution, before going into the detail of normal distribution, let's take an example and discuss about the frequency distribution. Let's talk about the histogram. We have to determine a histogram before, and then we can go toward the normal distribution. Now suppose we randomly select 2000 students in IIUI and collected their heights. We just take the random sample of, as I have already mentioned, what is meant by sample, what is meant by population. So if we have a whole International Islamic University, we have a number of 2000 and thousands of students in International Islamic University, and we just take randomly a sample of 2000 students in that and determine their height. So what we do then, we just tabulate those heights and we determine a class. So what is a class? If we have a height of a student, a height of students in inches, we represent it by x. So here we have one class, another class, third class, fourth class, fifth class, and sixth class. Okay, so we divide this whole data into classes, and first class include the height in inches from 60 to less than 62. Class 2 include heights of student from 62 to less than 64. Why we take less than 62? Because we are not including 62 in the first class, but 62 will be the part of next class. Okay, so we divide these whole 2000 students into number of classes, and we determine the frequency, that f represent the frequency. So what is that frequency? It is actually number of students having the height between 60 and less than 60, including 60 but less than 62 and not including 62. We have 320 students. We have 320 students with a height of 62 to less than 64. Similarly, 480 for the third class, 600 for the fourth class, 250 for the fifth class, and 200 for the sixth class. Now what is RF? That is relative frequency. Let's talk about relative frequency in next slide. Okay, so table 1 is the frequency and relative frequency distribution of students' height. The height of each student is continuous random variable. As I said, the height cannot be a whole number. It's not necessary that every student will either be having a height equal to 60, 61 or 62. It might be 60.5, it might be 60.7, it might be 61.2. So this height is a random variable and a continuous random variable. So let's x is equal to continuous random variable of height of students. Now what do we do here? How do we determine RF? From previous lectures in the concept of probability, we know that if an experiment is performed n time, if we have determined the heights, we have determined the heights of 2000 students, so each time determining the height of student is the experiment, and we have performed that experiment 2000 times, so n is equal to 2000 here. So if an event A occur, the event A is the number of students whose height is between 60 and less than 62. So that is the first event. Now we call it event A. That is event A. So what actually event A is? Event A, the probability of event A, the probability of event A is equal to frequency of first class, that is number of students in a first class with a height less than 62 and between 60, divided by total number. Total number we have is 2000. So 2000 is total number here, and f is the frequency, a number of students in that respective class. So if we calculate that, that will give us probability. How about if we determine that probability value for every class. So if we determine a probability value for every class, for the first class that give us 0.075, for the second class it give us 0.160, for the third class that probability value is 0.24, for the fourth one 0.3, for the fifth one 0.125, for the sixth that is 0.1. And as I have already mentioned that the sum of all probabilities is equal to 1, so if you sum up all, that will give you 1. Now we have these probability values. We have random variable, the random variable that is height, and height we have divided into number of classes. So we have the class 1, class 2, class 3, class 4, class 5 and class 6. So if we take these classes on x-axis and if we take this probability on y-axis, then it will give us a histogram. That will be a frequency distribution plot. Okay, so PA is probability of any event A is equal to F divided by N, that is known as relative frequency, and we can see that in slide, next slide. Okay, so if we plot that, if we plot these classes, class 1, 2, 3, 4, 5 and 6, we have different classes representing the range of heights, and if we plot that on if we develop a bar graph, simple bar graph, we call it a histogram because we have these classes. So the relative frequency, corresponding relative frequency we will get on a y-axis. The histogram and polygon of the distribution is in table 1 is shown to the right. So that is a graph which is showing a histogram for the height of students. Now what we do here, if in case of this interval, we have the first interval that is 60 to less than 62. Now we have the minimum value as 60. Let me rub all this, erase all ring. We have a minimum value of 60 and we have a maximum value of 72 here. So we have divided that equally and we got total 6 classes. If we take the interval value very small, for example, if I take the interval 60 to less than 61 instead of 62, if I take less than 61, so another one will be 61, instead of that it will be 61 to less than 62. What we are doing here is we are making the class very small. So if we take these classes very small, instead of these 6 classes we will be having total 12 classes. We will be having 12 classes. So with decreasing the size of interval, if we decrease the size of interval, we will be having more graphs and more bars. Sorry, not graph, this is single graph and we will having a number of bars. So if we decrease the size of an interval, we will be having more number because we still have to attain the bars between 60 to 72. Now what will happen here? Okay, we have 6 bars here, and what we do, we make a polygon. We start from one x-axis, then we touch all the bar center point of the bars. We touch all center points of the bars, these bars, and then we join these by a line. Now this line is actually a polygon that will pass through the midpoint of the top end of these bars, and that will give us a curve. Now if we increase these interval, the smoothness of this curve will increase, and that will be approximated to the probability distribution curve of continuous random variable. So that is actually a probability curve. A probability distribution of continuous random variable must satisfy the following two conditions. We need to satisfy these two conditions as well. Now, what is the first condition? The probability that x assume a value in any of the interval the class ranges from 0 to 1. We can see here for every class that is class number 1, so the probability value is 0.075. The class number 2, the probability value is 0.162. Probability value is 0.24. So the probability value falls between 0 and 1 for every class. That is the first condition that should be satisfied. Okay, so if we plot that on, as I have already plotted a histogram, and that is converted into a curve. So for any value x is equal to a and x is equal to b on the x-axis, so that area, the area under the curve will be between 0 and 1. Now, coming toward the next condition, the total probability of intervals within x can be assumed a value is 1. So the value, as I have already mentioned here, that sum of all probability is equal to 1. So if we take a curve, if we take a graph, if we take this area, let me draw up that. So all this area, all this shaded area under this graph is equal to 1. The probability of area under the curve is equal to 1, and that is also 100%. The total area under the probability distribution curve of continuous random variable is always 1. Okay. Now, what we have here, the probability that x assume a value within a certain interval is equal to the area under the curve between endpoint of the interval. As I have already mentioned in the previous slides, if we have on x-axis point A and point B, so the respective probability for point A and point B, all the area between that point A and point B will be the probability of A less than or equal to x, and x smaller than or equal to b is the area under the curve between A and B. We will represent it in that form. So the probability that height of randomly selected student lies between 68 to 70 is given by area under the curve from x is equal to 68 and x is equal to 70. Now if we, as I have drawn a smooth polygon in the previous slides, if we have the same example here and a value of 68 on x-axis, that will have a respective probability value on y-axis, and similarly 70. Now if we determine the percentage of student with a height between 68 and 70, that will be actually the area under the curve, which will be having a probability value, and if we multiply that probability by 100, then that will give us the percentage of students having a height between 68 to 70. Okay, one more thing, the probability of continuous random variable is always calculated for an interval. As I have mentioned in previous slide, the probability is always calculated for an interval. That will not be exactly for A or exactly for B. A is in case of discrete probability distribution. We have probability of x is equal to 1, probability of x is equal to 2, probability of x is equal to 3, but here we will not have such condition. We will be having a probability value in an interval. This is here we have the probability of an interval and not the probability of exactly one value. So we can say here that the probability that x assume a single value is 0. Probability of x a x is equal to a is 0, probability of x is equal to b is 0, but there will be some value for probability of a less than or equal to x less than or equal to b. So this probability will be having some value, but the probability of x is equal to a is 0. The area of line is 0 because the in continuous distribution we talk about the area and we are not concerned with one specific point. So since the area of a line is 0, okay, so as area of a line is 0, the probability of x is equal to 67 is 0. Since probability of x is equal to a is 0 and probability of x is equal to b is 0, so we also have this condition. We can say that probability of x greater or equal to a, smaller or equal to b is equal to probability of a less than x, x less than b. That is same. In other words, the probability that x assume a value in an interval from a to b is same whether or not a or b included. Okay, so if you include a or b, or if you exclude a or b, so that will be same. Now coming toward normal distribution. Now we know the concept of continuous distribution. Let's talk about normal distribution. As I have said that for probability distribution we will be having two important factors. One is mean and another one is standard deviation. This mean and standard deviation will give us the shape of probability distribution, as we have already discussed that for exponential distribution, for binomial distribution, for Poisson distribution. Similarly, we have this for the normal distribution. A normal probability distribution has a mean mu and standard deviation sigma and is characterized by its symmetric bell-shaped curve that satisfies the following condition. Okay, so normal distribution we will be having a curve like a bell shape. If we have a random variable x and if we have probability value on y, the shape of the normal distribution will be a bell shape and area under the curve will be equal to 1. So let's talk about these conditions. Okay, so the total area under the curve is 1. That is the first condition in the bell shape. The curve is symmetric about the mean. The mean is at the center. This is the mean, is represented by mu. That is the mean line. The line of symmetry divides the shaded region into two equal parts, 50% to the left and 50% to the right. So if we have a mean at the center, this bell-shaped curve is divided 50% at this point, 0.5, and this is 50%, that is also 0.5. okay, so this total is 1. The two tail of the curve extend indefinitely in both directions. The curve never touches but get very close to the horizontal line, such that the area under the region beyond on the left and to the infinity on the right is considered to be 0. So you can see here this curve, this area to the left and this area to the right, this extent but that never touches the x-axis. From the three graphs we need only both mean and standard deviation to find the area under a normal curve. So we will be having different shape of normal distribution, as I have mentioned that the standard deviation and mean will actually represent its shape. So if sigma is greater, the spread will be more. If standard deviation is greater, the spread will be more. So if sigma is smaller, the spread will be smaller. mean value will fall at same place is here. In this example we have mean is equal to 50 and the spread is 16, 10 and 5. So as standard deviation increases, the spread will increase. Okay, if we have standard deviation value same, that is equal to 5, standard deviation is equal to 5 and mean value, so mean value that will translate, if mean value increases from 20 to 40, the curve will translate along the x-axis in this direction. Okay, now this is a normal distribution curve. You can see here, this is the mean, this is the line of symmetry, this is the midline, and mean fall here. And this is mean minus 1 standard deviation, this area is mean plus 1 standard deviation. Now the region between mean, this is the region between mean minus standard deviation and mean plus standard deviation. Here the curve is downward, okay. Now if we go beyond mu minus sigma and toward the left and mu plus sigma toward the right, the point at which the curve changes in upward direction, so this point here, beyond this point, if we go here, it is concave upward. This is concave upward. Now this point is known as inflection point. The point where curve changed the direction is known as inflection point. So you need to remember the inflection point in normal distribution. Now a normal distribution can have any mean and any positive standard deviation. The mean gives the location of the line of symmetry. The standard deviation describes the spread of data. So you can see here mean values here, here, here. So mean is actually showing the translation of curve along x-axis, and standard deviation shows the spread of data. So in this curve the spread of data is more, and in this curve the spread of data is small, or in this comparing to the first A curve, the spread of data in B and C is less. So we can see here the standard deviation here is 1.5, but standard deviation here is 0.7. So more standard deviation mean spread is more, less standard deviation mean spread is less. Now here, which curve has a greater mean? So of course the curve that is translated more along x-axis in the right direction will be having a greater mean. So here the mean is this for this curve, and for this curve the mean is here. Now the 12 for the curve B, the mean is 12. For curve A the mean is 15. So the mean of curve A is greater than curve B. How about this, the curve which have a greater standard deviation? So here we have curve B spread which is more than curve A spread. So we can say here that standard deviation of curve B is greater than curve A. Okay, now there are some general terms you need to remember, that for any normal distribution, if we have a normal distribution having a mean value which is at the center of the curve, which divide the curve into two equal parts, 50% toward left side, 50% toward right side. So mean fall at the center point. Now the data for any kind of normal distribution, if the data is normally distributed, so for any kind of normal distribution, the area between mean and mean minus standard deviation, that area, that will be 34% of the whole data, or we can say the probability of value between mu and mu minus standard deviation is 0.34. Same for, because that is symmetry, so same for mu plus 1 standard deviation, that is 34%. Okay, how about the data between mu and mu minus 2 standard deviation? So that will be 13.5% plus 34%, and mu plus 2 standard deviation, so that data is 34% plus 13.5%. And the whole data between this whole data, if I let me change the color, so the whole data between mu minus 2 standard deviation and mu plus 2 standard deviation, that is actually the percentage is 95%. So 95% of the data falls between 2 standard deviation. For 1 standard deviation, 68% of the data fall, and the data falling for all this till mu plus 3 standard deviation, starting from mu minus 3 standard deviation till mu plus 3 standard deviation, the whole data falling between these is 99.7%, that will fall between 3 standard deviation. It's not 100% because this line is not touching, this area is not included, as this is not touching the x-axis, and we can approximate that equal to 1, but that is not exactly equal to 1. Okay, for a normal distribution, same like other distribution, we have a mathematical model. We can call it probability density function. Sorry, I have to make some changes here. Okay, let's make some change here. That is a probability distribution function, that is small p, for any random variable x. That is small p, actually that is a probability distribution function. Probability distribution function, I will write it probability distribution function. Probability distribution function, we can call it PDF. So we can call it PDF, and that probability distribution function, if you see an equation here, that is a quite complicated one compared to the other distribution. So there is a mechanism to simplify that, and what we do, we just transform the normal distribution into a standardized normal distribution, and we call it standard normal distribution. We will talk about this in next week lecture, but here I just want to give you an idea of standard normal distribution, that for a standard normal distribution we transform mu to 0 and we transform standard deviation to 1, and then we solve the problem instead of solving the probability equation. So what we do, we just transform this equation to a simple procedure, and we then perform analysis on this. But you can see here in this equation we have the mean and standard deviation for any random variable x. We have mean, we have standard deviation values, and by using, if we have these mean and standard deviation values, we can just plug in that equation and we can determine the distribution value, probability value. So as I said, this equation is very difficult to solve. First you need to, if you want to solve that for probability of x greater or equal to x, C and sorry, if you solve that for probability of x greater or equal to C and smaller or equal to D, so you have to use this equation which will give you the area under the curve. So instead of using that, we just use the concept of standard normal distribution, that is standard normal distribution, and a concept of z-score. We will talk about that in next week lecture, but in next lecture this week we will use MS Excel software, as I have already used that for the Poisson and exponential distribution to develop a histogram. How to make a histogram in Excel by using some civil engineering related example. We can determine mean and value of standard deviation, standard deviation of normal distribution in MX Excel. I will give you an idea how to determine mean and standard deviation of normal distribution, and I will try to develop a normal distribution curve in MS Excel by using some civil engineering example. So thank you for this class.